Hi all, let's see the next topic of Unit 2, Data Transfer Instructions. Contents. We are going to discuss about an introduction to what are data transfer instructions and types of data transfer instructions, as well as what are the advantages and disadvantages of data transfer instructions. So coming to the introduction, computer, it provides an extensive set of instructions. There are different set of instructions which are given to the user because of the flexibility to carry various computational tasks. So coming to the introduction, computer provides an extensive set of instructions to the users, the flexibility to carry out various computational tasks. So there are different sets of instructions which are majorly classified into three categories. The data transfer instructions, data manipulation instructions, and program control instructions. So data transfer instructions. What do you mean by data transfer? Data transfer is nothing but it involves the movement of data between the different components of a computer system. So, suppose you want to move the data from one part of the system to the another part, from memory to the registers, or from registers to the input output devices. So whatever it is, we need to transfer the data from one part of the system to another. That is done by means of a data transfer instructions. So data transfer involves the movement of data between different components of the computer system, such as from the processor to the memory, or between the registers, or across the network interfaces. So this movement of data is very essential to fetch the instruction from the memory, storing the result back into the memory location, or not only for that, to communicate with various parts of the system. The transferring of information is very important in the communication system. So the data transfer instruction causes transferring the data from one location to another without changing the binary instruction content. So the content of your instruction remains the same, just you are going to transfer the data from one part of the system to the another. So that is the main aim of a data transfer instructions. Coming to the next set of instructions, we call it as a data manipulation instructions. So they perform manipulations on the data and change the contents of the data. So example are the perform operations such as arithmetic operations, logical operations, shift operations. All these operations they are going to manipulate the data. So that's why we call them as data manipulation instructions. The instructions which are performed to perform manipulations on the data are called as a data manipulation instructions. Next, the program control instructions. Program control instructions, they mainly provide decision making capabilities. So to change the path taken by the program when executed in the computer, we implement the concept of program control instructions. Using these instructions, the control of your program changes from one part of the program to the another part. So those are called as a program control instructions. Now we are going to discuss in this lecture, we are going to mainly discuss about the first type of instructions which are called as a data transfer instructions. So this table will give you the different types of data transfer instructions that are available in the computer, and we'll see each one of them in detail. The first one is a load, and the symbolic mnemonic symbol it is represented by LD. Next is a store, ST. Next, move, represented by MOV. Exchange, which is represented by XCH. Input, in, output, out. Push, and pop. These are the different types of data transfer instructions which are used in a computer. Let's see each one in detail. The first type of an instruction is a load instruction. So we have already discussed when we are discussing about different types of instructions like memory reference, register reference and all, we come across this load store instruction. So the load instruction is mainly used with respect to the memory. The load instruction is used to transfer the data from the memory to a processor register. So the contents of the memory can be loaded into the processor register with the help of an instruction called as a load instruction, and the processor register will be usually an accumulator. So for example, if you consider load, you can have R1 comma R2. So here this particular instruction loads the contents of the memory location which is pointed by register R2 into the register R1. Whatever memory location is pointed by the register contents of the register R2, they are loaded into the register R1. This is called as a load. Coming to store instruction transfers the data from the processor register to a memory. So here store it is represented as str, load it can also be represented as ldr. So store is used to store the contents of register r3 into the memory location which is pointed by the register r4. So this is the use of load and store instructions. Next, coming to a move instruction. So the move instruction transfers the data from the processor register to the memory or from the memory to the processor register, or it can be done between the any two registers also. So from the register to the memory or memory to the register or to the register to register. So that can be done with the help of a move instruction. So the source can be here either a register or a memory location or an intermediate number, anything. So for example, if you consider move AX comma BX, it copies the contents of register BX into register AX. So this is the source register and this is the destination register. So if I say move S1 comma CX, it copies the contents of register CX into the memory location which is pointed by SI. Okay. Similarly, these are other examples. Move AX comma 5000H. It copies the content of 5000H into the register AX. So move AX comma SI. So the whatever contents that are present at the memory location pointed by SI, it is moved into AX register. So the same thing here. So the same thing applies in all the cases. So these are the different types of move instructions. Next, coming to exchange. Exchange is also one of the type of a data transfer instruction where your information can be exchanged. So the exchange instruction swaps the information either between the two registers or between a register and a memory location. So if we take an example here, XCHG, exchange is represented by, you can represent it XCH or XCHG. So this is when you are representing in a brackets, it means it is a memory location. If you are representing like this, it means it is a register. So the contents between the memory location specified by address 2050 and the contents of the register both are swapped, which means the contents of AX are moved to this particular memory location and the contents of the memory locations are moved to the AX register. They are exchanged. So similarly here again BX and AX. So this is between two registers. The contents of two registers will be exchanged. So this is called exchange instruction. Next two instructions are input and output. So the input instruction transfers the data between the processor register and the input terminal. So between the input terminal and the processor register, the particular information will be exchanged. So AX and DX. So one is an input register and one is the input terminal and other is a processor register. Between these two, the particular information will be exchanged. The output instruction transfers the data between the processor register and the output terminal. So this is transferred between the register, and so in this case this is a memory location and this is output terminal. The information is exchanged between the memory location and the output terminal. Next two instructions are push and pop. So the push and pop instruction transfers the data between a processor register and a memory stack. So whenever the information has to be pushed into a stack from a memory register, so similarly whenever information has to be popped, the topmost value will be popped out from the stack. So in order to perform a push and pop operations on the stack, we implement push and pop instructions. So push AX pushes the contents of register AX onto the top of the stack. If you consider pop BX, whatever information which is present in the top of the stack, that is the topmost value from the stack, will be placed into the register BX. That is called push and pop. So here we are seeing an example in terms of different types of addressing modes. How this load to I'm considering an instruction called load to accumulator, and this particular instruction is executed by different types of addressing modes. How the data transfer takes place, that is how the the information is transferred from one register to another, that is represented here. In case of direct addressing mode, whatever is there in that particular memory address. So load to accumulator, we are loading a value into the accumulator. So which value, whatever is represented by the address part of the memory. So that is loaded into, transferred into the accumulator. So the data transfer takes place from the memory address, the memory word which is stored at a particular address of the memory to the accumulator. In case of indirect addressing, it is labeled as at the rate. If I am specifying at the rate, it means it is an indirect address. So in the memory, we get an effective address. That particular effective address, if you refer, you get your operand. So m of address. So through this, the particular operand can be accessed and that is loaded into the accumulator. If I am specifying it as a dollar relative address, dollar means PC. It is added to the contents of the PC. So we call it as a relative address. So here the effective address can be calculated as the contents of the program counter plus address part of the instruction. So this together will be the effective address. So if you access the particular memory location using the effective address, your operand will be, you can find your operand that can be loaded into the accumulator. Next, coming to immediate address, implicit or immediate addressing mode. In this case, it is represented by this hash, which means this is a number. So whatever is there, that is an, it means it is an whatever is next to this hash, it means it is an operand. So that particular operand value is loaded into the accumulator. In case of index addressing mode, the contents of the index register are added to the address part of the instruction. It is represented by address of X, which is the index register address. So the contents of the index register XR plus the address part gives the effective address of the memory location. So if we access M of this particular address, the actual operand will be present, which can be loaded into the accumulator. In case of a register addressing mode or register direct addressing mode, whatever is the register contains an operand which is loaded into the accumulator. In case of register indirect addressing mode, whatever is the content of the register, that is represented by parenthesis. So whatever is the content of the register, that is the effective address. When you access that particular address of the memory, actual operand is present which is loaded into the accumulator. In case of an auto increment addressing mode, the particular contents of the register is nothing but your effective address, which is first accessed. The particular memory allocation is accessed based on the content of the register, and that will be your operand, which is loaded into the accumulator. And once the value is loaded into accumulator, the register contents are incremented by 1. So this is an auto increment addressing mode. So R1 plus 1. Suppose if R1 is 100, 100 plus 1, 101 is loaded into the register R1. So this is how the register transfer operation takes place. So this is nothing but transferring the information from a memory location to accumulator or from the register to accumulator, whatever it is, the transfer operation is taking place in all the different types of addressing mode. So this is an example of data transfer instructions. So ADR stands for an address. NBR means it is a number or an operand. X represents an index register. AC represents an accumulator register. If it is at the rate symbol, it specifies it is indirect addressing. Dollar symbol before an address makes address relative to the program counter. If you have a hash character precedes the operand, which means it is an operand in an immediate or implicit addressing mode. So coming to the advantages and disadvantages of data transfer instructions. Advantages, we can perform the operations very fastly using a data transfer instructions, and the memory usage is also very less for these instructions, and the communication can be improved very well because they are simple instructions and they execute fastly, and you can handle big data, large amounts of data in a simple manner using a data transfer instructions, and they are more accurate, and coding is also very easy. In terms of disadvantages, they require certain resources to be used, whether it is a registers or a memory locations. So some resources are being used, and they require the use of certain level of bandwidth. And security hazard, they are not very secure compared to the other remaining types of instructions. So these are the advantages and disadvantages of data transfer instructions. Thank you.